What's up? It's Coach Hyde. Got your little Hyde Science vlog. Before I go out and check to make sure nobody falls off the bus on bus duty, gets ran over, or anything like that. Gotta keep the bus ramp safe. That's what I do. I also teach science though. So what we're gonna go over right here is we're talking about ions mainly. Ions is our main focus. So we're gonna review a little bit of just the atom and how to find protons and all that. And then we're going to track a couple things as we transition from just our normal balanced atom to an ion. So the ones we're going to be looking at is lithium, which is a metal, oxygen, a non-metal. So I know this, all right, because I can't do this. Oxygen is here. Okay, it's up that way based on our stair-step sign. It's on the non-metal side, right? Lithium is here. It's over here. It's on the metal side. So things we're going to be tracking is the number of electron energy levels, protons, neutrons, electrons, and the number of valence electrons. So first we're just going to start out by mapping out our lithium and oxygen nucleuses. So here's lithium, right? And I got the numbers written in the box up here. We got an atomic number of 3. This tells us they got 3 protons. It also tells us I'm going to have a total of 3 electrons. We'll get that to a minute. This number here is our mass. We'll round this up to 7. So that means there's a 7 total atomic mass units inside this nucleus. Well, 3 of them are protons. So how many more do I need to have 7 total atomic mass units? 4, right? So that means I have 4 neutrons. Now the total mass of my atom, of my nucleus, is 7. So, like I said, this atomic number also means we have 3 electrons. Well, how do we map them out? So, first off, how many energy levels are there? So lithium is here. Okay, it's in the second row down. So it's going to have 2 energy levels. So I have 1 energy level here, 1 energy level here. So where do I put these electrons? Well, in the first energy level, this one, right? There's 1 hydrogen and 2 helium. There's 2 elements in the first row, so I can put 2 electrons in the first level. So 1, 2. All right, so that level, that shell is full. Now the next one has 1, 2, 3, 4, 5, 6, 7, 8. I can put up to 8 in this next level here, but I only have a total of 3, so I only need to put in 1 more. So this is our mapped out Bohr model of lithium. We do the same thing for oxygen. Okay, oxygen has an atomic number of 8. This means we have 8 protons. The mass is 16, so that means I have 16 atomic mass units inside the nucleus. Okay, right? So I already have 8. How many more do I need? 8. Right. 8 and 8 is 16. My total mass of my nucleus is 16. Now, like I said, 8 also means we have 8 electrons. Well, first, how many levels are they going to go in? So oxygen is here, right? It is in the second level. So I'm going to have 2 levels again. Okay, just like before, right? The first level still only has hydrogen and helium. It still only has 2. So I can put 2 electrons in my first level, right? I can put up to 1, 2, 3, 4, 5, 6, 7, 8 in my second level, but I need a total of 8. I've already put in 2, so I only need to put in 6 more, right? So 1, 2, 3, 4, 5, 6. So we have mapped out our lithium and our oxygen. In our base thing, we have 1, 2 energy levels. We have 3 protons. We have 4 neutrons, 3 electrons. This is our valence. Our outer energy shell is our valence. So we have 1 valence electron. Over here, we got 8 protons. We got 8 neutrons. We got 2 energy levels. We got 8 total electrons. And in our outer level, we have 1, 2, 3, 4, 5, 6. A little quicker way to figure out our valence electrons is this. So lithium is here. Okay? This row tells us there's 2 energy levels. This number up here tells us how many valence electrons there are. So it's in group 1. It has 1 valence electron. Oxygen here is in group 16. But you can't have 16. You only have up to 8. So you can have 16, but it has 6. So we kind of cover that 1 up, we'll find out we got 6. So now we're going to make it an ion, right? Another way that I could represent these, I'll do that in a minute. All right, so we're going to make these into an ion, right? Now I'll go ahead and put it up. Go ahead and put it up. So lithium could also be this Li. If I write Li, it stands for everything inside of this atom except the valence shell. So lithium stands for all of this. I'm going to put 1 dot. That's going to stand for the valence electron. So for oxygen, right, the O stands for all of this, right, except the valence shell. So I put the O represents all of this, but I got to put in my 6 valence electrons. You start by filling up the empty shells or empty subshells, I guess. So then you you start pairing. So this is the Lewis dot structure of these. Now we make this an atom, right? They all want to be like the noble gases. They want to have a full valence shell. All the noble gases, helium, neon, argon, xenon, all of them, they got full valence shells. So lithium has a choice. Don't really have a choice, but let's just say it has a choice. It could fill this current valence shell by adding 7 more electrons, right? So I added 1 here, 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 here. That would fill its valence shell. That would make it just like the noble gases. But that's a lot of work, right? We'll assume it takes just as much energy to add an electron as it does to lose an electron. So doing this is 7 times harder than the easy way. Okay? What's the easy way? The easy way is just to lose 1. Okay? So by losing this valence shell, right? My eraser. This takes away this energy level. Okay? So we don't have 2 energy levels anymore. We have 1. Okay? That leaves this as our valence shell now. And we can only put 2 in there, right? Well, there's already 2 in there, so it's full. So this gives us that noble gas feel, like helium, right? We are full, we are stable. We no longer have 1 valence electron because this is now our valence shell. So now we have 2. We no longer have 3 total electrons. 1, 2, we only got 2. Okay. We still got 3 protons. We can't change that. If we change that, it's no longer lithium. And we still got 4 neutrons. If we change that, we got isotope. So now there are 3 protons. 1, 2, 3, and there are 2 electrons. Okay, opposite charges cancel out. 1, 2. We're left with 1 extra positive charge. So this lithium now has a charge of +1. Every single element here, right? When they become an ion, will have a +1 charge, +2 charge, +3 charge, 4, -3, -2, -1, 0, because these don't ionize. They're the noble gases. So that's lithium. Now let's look at oxygen. Oxygen has 6 valence electrons. It wants to be like noble gases too. Everybody wants to be like noble gases. They're cool, man. Noble gases is where it's at. So they have 2 choices, technically. Again, they can lose 6, give away their outer shell like the lithium did. That's a lot of work. You'd have to lose 6. You'd have to get rid of 6 electrons. That's too much. Because we can just add 2. If we add an electron here, we add an electron here, how many we got? 1, 2, 3, 4, 5, 6, 7, 8. We have 8. This is called an octet. It means 8 valence electrons, a full stable valence electron shell. So this is what oxygen will do. Your nonmetals are going to gain electrons. Your metals are going to give or transfer away electrons. So by doing this, we now have an electron here and here. Okay. We still have 2 energy levels. That did not change. Still have 8 protons. Still have 8 neutrons. That did not change. Now, before we had 8 total electrons. Now we added 2, right? We should have 10. 2, 4, 6, 8, 10. How about that? Right? 10. We got 10 total electrons now. Valence electrons, we had 6. We added 2, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, in the ion form, we have 8. Okay. So we have 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. And we have 10 total electrons now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive negatives cancel out. We're left with 2 extra negatives, right? So 1, 2 extra negatives will make us -2. All right, so our charge of the oxygen ion is -2. Our charge of our lithium ion is +1. So hope that's helped. Just kind of quick review of what we can learn from this. These numbers here, okay, they're going to tell us how many energy levels there are in our base atom. Now, once it becomes an ion, all bets are off. Lithium should have 2, right? It starts with 2, but once it becomes an ion, it gives away those outer ones. It drops down to 1, right? It also gives away those, valence electrons, so the number of total electrons and all that change. Oxygen, also in the second row, has 2 levels. But when it becomes an ion, it just fills that current level. It doesn't gain a level. It doesn't lose a level. It just stays kind of there. It just fills what it already has. Now these numbers on top, they tell us valence electron. From that, we can kind of skip all this dirty work and make an assumption on the charge of the ion it will lose. All right, it will have. So group 1 has 1 valence electron. So it will give that valence electron. Group 2 has 2, right? So will it gain 6 or will it lose 2? It's going to lose 2, right? If you lose 2 electrons, you'll become +2. We skip these. We can't do our cool little trick with these. 13 has 3, so it will give 3, not gain 5, which will make it negative or +3. Group 4 is right in the middle. You go either way. Group 15, right, has 5. So the easiest thing for it to do is to gain 3. If you gain 3 negatives, you'll be -3 charge. This group has 6. It will become -2 charge. This group has 7. It will become -1 charge. This group on here is the noble gases. It will not ionize because they're already full. All right, got to go to bus duty. Got to go make sure nobody gets hit by a bus. All right, catch y'all here in about 10 minutes, 15 minutes, something like that.